I can directly go to the program formulation. So as I have said, do you see the paper now?
Yep.
So exactly what I have to do, given this situation, is to find a way to, as you say, Maura, to measure, to quantify this interference cancellation, right? And so I have found, or I have done it in a certain way that here you can see some numbers. I will explain them now. And I want to emphasize that this is not necessarily like realistic numbers. I just put numbers because it's a bit like nicer to the eyes, because otherwise I just get variables everywhere. It's a bit ugly, but yeah, so I will explain now. What the functional split can do, or what the functional split affects, is two things. The traffic in the front hole, and this is like a limitation I have to deal with, or some cost I have to pay, and I'm limited by the front hole network to this. But the other thing that it affects is the interference I get for each user. So I'd say that the user U is receiving some capital I U interference from all the other base stations apart from its home base station. And I can just say this is just a summation of the interference coming from each base station. Okay, but this will be just if I don't have any kind of interference mitigation, cancellation, coordination, whatever. So this is just like pure interference. But I assume, and this is how I modeled it, that if I have some functional split, I might be able, or I will be able to mitigate or to reduce, at least to some extent, the interference from that base station. So for example, I can consider that I have 4 available functional splits, and I index them with this xg going from 0 to 3. And I assume that, for example, if x is equal to 0, this can be like a PDCP RLC split, which means that I have only centralized the PDCP layer and I cannot do basically any kind of special interference coordination. So in that case, I multiply the interference by a factor of 1, so I don't cancel interference at all. With x equal to 1, this can be, for example, MACPhi or whatever. I multiply the interference I get, so this is like the average interference I will get by 0.2. And then if I get x equal to 1, so a higher functional split, 0.01, and 3, 0.001. So again, these are just numbers I just somehow made up, so they're like an educated guess based on what I have read and so on. But these are not necessarily realistic numbers. And for formulating the problem, I don't need this to be a specific number. The only thing I need is that this decreases as this increases. And this will be always true, because for a functional split, I assume you will get always the same capabilities that you get with a lower functional split, plus some other capabilities given the new functions you are able to centralize. So it's always, like say, decreasing, so you don't lose anything. Or if you somehow lose it, it's because you have arranged them the wrong way. Okay. So given that I have some interference cancellation factor, and this is how I modeled it, I say that now the interference that a user receives is not just the summation, but is the summation of the interference received by each base station multiplied by this cancellation factor. But another problem that I have is that I cannot say my home base station is fully centralized, so it's like x equal to 3, so it will be able to cancel the interference from everywhere. This is not true, because if the interfering base station is not centralized, I won't be able to know its transmitting signal, so I won't be able to cancel it, at least using techniques available from the centralization of these functions. So I'm actually limited to for each pair of base station to the minimum centralization of both of them. So if my base station is centralized, but I am being interferenced by some non-centralized base station, the network cannot know at all what this base station is transmitting, so I will be receiving full interference from this base station. If it's centralized a bit, I will be benefiting just from the least centralization. So I don't intend to select just one functional split for each base station and expect that this will lead to an interference cancellation. I have to look actually into the minimum interference cancellation factor of each pair of base stations.
I have one question.
Yes, please.
Why do you want to have this degree of freedom? Because you could just simply consider the pair, but probably if I understand it right, you want to have degrees of freedom on which interference cancellation is in which base station because different pairs are done, right? So the same the interference from one base station could be cancelled in two base stations in two different ways. Why you want to have this? You want to have the minimum. You could simply consider the allocation, the cancellation resulting from a pair of base stations.
Yeah. Yes. Actually, this is exactly it. So
Okay.
this is like considering every pair of base stations. So it's like a equivalent formulation. I can go instead of going from G equals, so this is like the index of the base station from 1 to the number of base stations. I can go from each pair of base stations, but then I will have to exclude those pairs of base stations which don't include my home base station.
No, it's just because the minimum. I was wondering why you wanted to have this per base station and not as a direct pair, because in the formulation it then changes to have a minimum or maximum, things like this.
Yeah, exactly. Actually, so this, as you say, this can be formulated instead of the cancellation factor, the minimum index, also as the maximum of the cancellation factors, because this increases as this index. No, sorry, this decreases as this index increases. So this is just like some equivalent formulation. But as you say, so one problem with this is that this is already non-linear.
Exactly. Because with me, this is why I was wondering why you had to have this, let's say, these two variables. But probably, I don't know, it's because you. I would.
No, but as you say, so an equivalent formulation, and actually this is what you can use then in the optimization problem later on, is just replace this minimum of these two variables by a single variable modeling the cancellation factor of this pair of base stations. So this is exactly the way of doing it, but somehow it's a bit less intuitive. So for the first formulation, I just use the minimum of each pair of base stations.
To have it fully generic and then you talk this later. I understand.
Exactly. But exactly, the way of tackling this is to replace this by a single variable. At least this is what I could find so far. Okay. Yeah, but good points, actually. Any other question at this point?
I have some comments related to your assumptions being based on downlink transmission, because if it's an uplink downlink transmission, then the way the interference cancellation would work may differ, but I'm not detailing those because I think your whole scenario is based on just downlink transmissions.
Yes, it's mostly downlink, but maybe it's a good comment. So what do you mean by uplink downlink? So do you mean that it can interfere? Yeah.
Exactly. What I mean is if an interfering base station that is having a downlink transmission that is fully centralized, and then this interference is perceived by an uplink transmission of a user by the base station, and then in that case, since the interfering message would be known by the central entity, it can be fully cancelled, and then the whole effect of it can be totally removed from the uplink message.
Actually, it's a good point. So far, I have assumed that uplink and downlink were totally separated. So, for example, as in LTE, you have two different frequency ranges that they don't affect each other.
Okay. So STD scenario.
It is true that in 5G you can have like this resource sharing between uplink and downlink. So this actually might happen, which will complicate the problem even more. Okay, I will think into this. Maybe this is not something I can, or maybe it's something I can ignore for the moment. But it's a good point actually. This can, okay, but maybe I'm thinking now. Maybe it will just influence the average interference cancellation factor.
Exactly. Yeah, or how you formulate this. This is what I wanted to comment.
Yes. Okay. Yeah. No, I will think of this. It's a good point. Okay. Okay. Thanks for the comment. That is good.